title this here, you can call this the graphs of y equals sine x and y equal cosine x. Okay, so we're going to learn how to graph these on a coordinate plane. Okay, no. Okay, now for the most part, you're going to sketch them. Now I have some special graph paper for this, but for the most part, you can just sketch this. Okay, I'm going to email you that graph paper. If you want to print some out and use it, you can. It's probably a good suggestion when we get closer to the test that you do that, because on the test, you will graph on my special graph paper that I make for trig graphs. Okay, so you can get used to it. Now, let's do what now? Graphs of sine and cosine. So y equals sine x, y equal cosine x. We're going to look at those graphs. Daniel, would you pass these out for me? Now, we're not really going to look at any of these that are on the worksheet here. That's just for later. There's some problems that you're going to do, okay? Get your graphing calculator out, because we're going to check our graphs with our graphing calculator in a little bit. Now, let's look at what y equals sine x looks like on the coordinate plane. Now, what I've done here is I've drawn the unit circle, and the only ones that I've named here are the quadrantal angles. Okay, does that make sense? Y'all remember what the quadrantal angles are? They're not the angles that are in the quadrants. They're the angles that are on the axis. Okay, so the ends of the x and y axis. Now, what we're going to do, we're going to look at this equation, y equals sine x, and we're going to fill in a t-table. Now, we only do the t-table for when we do the graphs from the very beginning. Okay, so you'll only see me do two t-tables, one for sine x, one for cosine x, and then from there on we just pick up a pattern. Now, so let's start like on my unit circle. Okay, I'm going to start at the x value there of 0. Okay, and I'm going to go around counterclockwise. So what comes next after 0 on my angles that I've got labeled? On my angles that I've got labeled on my circle. Pi over 2. Okay. And then what's my next one there? Pi. All right. And then 3 pi over 2. And then all the way back around to 2 pi. Okay. Now, the y value right here is going to be, well, what's the sine of that angle? Okay, so at 0, what's the sine of 0? Okay, how do we find the sine on the unit circle? The y coordinate, right? So what's my y coordinate there? 0. Okay, now let's go to my next angle. All right, pi over 2. So at pi over 2, what's the sine there? 1. All right. Okay, at pi, what's the sine there? All right, back at 0. All right, now at 3 pi over 2, the sine would be right -1, because we're right, sine is the y coordinate. All right, and then back at 2 pi, the same ordered pair we started at, it'll be 0. Now, do you kind of see the values? And this is going to be a curve, by the way. It's going to go up and down. Do y'all see the y values that it's going to bounce back and forth in between? Yeah, 1 and -1. Okay, that 1 and -1 is called the amplitude. And so this is a curve, and the curve is going to go, the highest point will be at 1, the lowest point will be at -1. Okay, now let's sketch the graph. Now, when we do the graph, we don't do the entire graph, but we only do what's called one period. Okay, the period is how long does it take to make the curve to make a complete cycle. Okay, so think about here past 0, we've got 1, 2, 3, 4 angles past 0, right? So we're going to do always here. 1, 2, 3, 4. Okay, so that first one was pi over 2. All right, let's just keep going. So we got what? Pi, 3 pi over 2, and then 2 pi. Now, the way that we do that for the rest of the graphs is going to be different. Okay, but this is for the first one. We're just kind of get used to it. Now, so let's start off. All right, when x is 0, y is 0. So we say the curve starts off at the origin. Okay, so I'm going to put a point on the origin. Now, all right, at pi over 2, what's the y value there? 1. Okay, so at pi over 2, it's going to go up to 1. All right, now at pi, where does it go to at pi? Back to 0. All right, at 3 pi over 2, goes down to -1. So we'll put down here -1. So we got 1 to -1. So at 3 pi over 2, it's going to be down at -1. And now at 2 pi, it goes back to 0. Now, do y'all are you starting to understand the cycle here? What's it doing? It's going back and forth in between -1 and +1. Okay, so this one starts at 0, goes up. So this is like a curve. Okay, and really, sine curve and cosine curve have lots of applications. Okay, it's really called in physics. You call it simple harmonic motion. All right, and a lot of things it does is, like, you ever seen brain waves? How they go up and down like that, or a heartbeat? Okay, really, those are just estimated sine and cosine curves. Okay, so we can do all those. You know, anything that goes back and forth between a number that oscillates like that could be done with a sine or a cosine curve. So they have lots of application. Now, that's the sine curve. All right, let's do the cosine curve now. Okay, so basically we just use the same circle. Okay, but when we look on our unit circle, the cosine value is which one in my ordered pair? The x. Okay, so now we're going to start at 0 and go all the way around to 2 pi. So we'll go again 0, pi over 2, pi, 3 pi over 2, and then 2 pi. All right, so now what we're going to do, we're going to take each of these little x values there, and we're going to put them in for x and see what we get for y. Okay, so let's take the 0. All right, so we put in 0. All right, what's the cosine of 0? 1. Okay. All right, let's go to pi over 2. All right, what's the cosine of pi over 2? Yes. No. It was an arrow. I was pointing to it. All right, at pi over 2, what's the cosine? 0. All right. At pi, cosine, the x coordinate there would be -1. All right, 3 pi over 2 would be 0. And at 2 pi, it's back at 1. Now, you see how this one also basically does the same thing? It goes back and forth in between -1 and +1. The only difference between the sine and cosine curve is the starting point. You remember where sine started? Sine started at the origin, okay? Well, cosine is going to start up at 1 instead. Everything else about it is pretty much the same thing, okay? Now, let me show you how we actually do the period when we're not going to see this from a t-table, okay? So after the origin, you have 4 angles. So you always do this. You go 1, 2, 3, 4. Okay? Now, the last unit we put there is the period. Okay? And we say the standard period for cosine and sine is always going to be 2 pi. Now, we'll change that up in a little bit, and I'll show you what changes the period later. Okay? But for right now, we said that the standard period is 2 pi. Okay? Now, what I'm going to do to figure out the other units is just keep taking half. Okay? So halfway would be right there, right? So what's half of 2 pi? Pi. Okay. What's half of pi? Will be right there. So what's half of pi? Pi over 2. So each unit on my graph is a pi over 2. So this is like 1 pi over 2. If I said this differently, it would be what? 2 pi over 2. So this one that's missing right there would be 3 pi over 2. Okay, that's 3 pi over 2. And then this one would be 4 pi over 2, which is 2 pi. Okay, so we don't always just look at a t-table and get the values because we're not going to see the t-table in every other example. Now, we're going to go, where did it bounce back and forth in between there? All right, 1 and -1. Okay, and our first starting point, instead of starting at the origin like sine does, cosine starts at 0, 1. So it starts up here. Now everything else is the same. Okay, so I really don't have to look at my t-table chart to figure out what's going to happen. See, 1 is the highest point, right? -1 is the lowest point. So if it's at 1 right now, then it's at the highest point. So it has to go down from there. So at pi over 2, where is it going to be at? 0. Okay, I could look on my chart and get that. Now, at pi, it's going to keep going down. So at pi, it's going to be down at -1. At 3 pi over 2, it's going to be back at 0. And then at 2 pi, back up at 1. Okay, and what always happens with a complete cycle, which is called the period, is that it always ends where it started. It started at 1, right? Where did it end at? 1. And it hit all 3 values, which was -1, +1, and 0. So now, I'm going to draw my curve. That's my cosine curve. Okay, so these are just the basics here. Okay, now what we're going to do in today's lesson is we're going to mess with it a little bit. We're going to look what happens when we throw like a number in front of the cosine, okay, or what happens when we throw a number in front of the x right there. Okay, so we'll look at some examples. Now let me kind of summarize with you just a little bit from this page. Okay, so think about sin x. Okay, think about the graph. All right, I know it's written up there, but let's say, where did it start at? It started at the origin, and then it went up, right? Okay, so sine starts at the origin and goes up. So, I'm not going to draw my unit circle every time I have to do a sine or cosine graph. Okay, we just did that for the first one, so we could get the basics. Okay, so it starts at the origin, and then it goes up. All right, now cosine. So cosine didn't start at the origin, it started up at 1 and then went down. So now, let's see if you guys can figure out what would happen if we throw a negative in the front. It's the opposite, right? Okay, so I'm not going to write it out. Now, if you want to write them out, you can, and then I'll say it for you, okay? But y equals negative sine x, it's still going to start at the origin, okay? Still starts at the origin, but then if it's negative, it's going to go down to -1 instead of up to +1. Does that make sense? Okay. Now, so what about, see if you can predict negative cosine. So it would start at -1 and go up. Okay. So negative sine x still starts at the origin, but it goes down. And negative cosine x, instead of starting at 1, it starts at -1 and goes up. Do y'all want to you want to sketch the graph of those real quick? No? Okay. So, all right, we won't do it then. All right, now let's look at some examples here, and then we're going to start changing some stuff. Now, what we're going to do with this one, we're going to do a sine curve, but we're going to throw a number in the front of it. We're going to throw the number 4 there. Okay. Now, this value in the front, this 4, is called the amplitude. Okay, and so what we usually use for it is a capital A. So it might look like this: A times sine x. Okay, so A stands for amplitude. Now, let me just tell you what it actually does to the graph. All right, you know how on the y values, the graph bounced back and forth between -1 and +1? Instead of -1 and +1, it's going to bounce back and forth between -4 and +4. That's all it's going to change. Okay, so instead of going to visualize it from -1 to +1, it's going to go from -4 to +4. So that's going to make the curves taller, right? It would make them shorter if I did what, a smaller number in the front, like a fraction. So if I did 1/4, the curves would be really, really short. If I did 4, it's going to make them taller. If I did 8, they would be really tall. Okay. Now, the way that we figure the amplitude is equal to, it's not just A, but it's the absolute value of A, which tells me it doesn't matter if it's negative. Okay? The negative doesn't change. What the negative does is change the graph like we said earlier. Okay, like sine here starts at the origin and goes up. If that was a -4, it would start at the origin and go down. That's the only thing the negative would change. The negative doesn't really change the amplitude. Now, we're going to write this always next, the period. Now, for right now, all you know that every period for right now is 2 pi. Okay, just go with it. I'll show you how we change up the period in just a little bit. Now, let's graph this one. All right, so see if you can remember some of these aspects, because I'm giving you like a lot of stuff to do to think about today. All right, on my x-axis, okay. All right, how many did I go out every time? 4. All right, 1, 2, 3, 4. And the last one, right, 2 pi. The last one's going to be whatever the period is. Now, in just a little bit, that's going to change. Okay, now, so do halves. What's halfway right there? Pi. Half of that's pi over 2. So each unit is a pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2. And then, of course, 4 pi over 2 would be 2 pi. Now, on our other graphs, we did this. We do like what, 1 and -1, right? But now the amplitude is going to change that. So instead of 1 and -1, it's going to be 4 and -4. So that's 1 and -1. So we're going to go up a little bit taller. So we got, let's see, 1, 2, 3, 4. Okay, 1, 2, 3, -4. Now you don't really have to count out like that too. So you just go up a little bit and call it 4, go down a little bit and call it -4. Okay. So really what happens on all these graphs, the graphs, they're all going to look the same. What's going to change on them is the numbers. Okay, and that's really all that's going to change is the numbers on the graph. Now, so now let's graph it. So what about sine x? All right, where did it start at? All right, starts at the origin and then it goes up. Now we used to say it would go up to 1. At pi over 2, it's not going to go to 1. It's going to go up to 4 because we've changed the amplitude. So the curves are going to be taller, like me. Okay. Now at pi, did 0. Okay. And then at 3 pi over 2, it's going to go down to -4. Y'all see how it cycles? Just goes through the 3 numbers. Okay. And then 2 pi would be at 0. Okay. So here we go. Let's just connect the dots. There goes our sine curve. Okay. Now, where did it start at? Started at 0, so it ends at 0. Okay. Now, do y'all want to do? You want to do an amplitude one, where we do cosine, or you just want to skip it? Skip. Okay. Really, cosine wouldn't be that much different. if this was a cosine graph, instead of starting at the origin, we would start up at 4 and go downwards. Okay, now let's talk about this. What if it was -4? Well, it'd still start at the origin, but it would go down to -4 instead of up to +4 for sine. If I had -4 sine, okay? Now, so would that mean the amplitude would be -4 then? Mm-mm. The amplitude is always positive, okay? Because it's the absolute value of it. All right, now, so the amplitude usually is the easiest aspect of the graph, okay? It usually is. Now, one of the harder aspects is when we start changing the period, okay? Let's look at this idea here, okay? So we have y equals, all right, I'm doing a general form now, so this is not an example, okay? Y equals plus or minus a, so that a stands for amplitude, okay? And we're going to say sine, it could be cosine there, it doesn't matter, okay? Of, and now what I'm going to do is I'm going to mess with it, and I'm going to put a number in front of the x, okay? So I'm calling it b, all right? Just as, so we just use a, b, and we'll add a c and a d later, okay? But the b, the coefficient in front of the x, what this is going to do is it's going to change the period, okay? So if I don't have a coefficient there, the period is just 2 pi. All right, but when I put something different there, it's going to change the period. So let's kind of recap the amplitude just a minute, abbreviate. So how do I find the amplitude? It's A. Is it just A? The absolute value of A. So it doesn't really matter if it's positive or negative. That's why I put plus or minus up there. Okay. Now, the period. Okay. Now, if I don't have a coefficient in front of my variable x, then the period is 2 pi. But if I have a coefficient, the period changes. It changes to 2 pi divided by that coefficient. Okay? So the period ends up being 2 pi divided by b. Okay, so when we start throwing numbers in the front, that's going to change the period up. So remember how at the very last number was 2 pi? When I put a number in the front, it's not going to be 2 pi anymore. All right, let's look at an example of that, okay? So let's do a cosine graph since we just did a sine graph, okay? Let's do 2 times cosine of 4x. Okay, now let's get the easy stuff out of the way. Okay, all right, what's my amplitude? 2. Okay, now my period here. Okay, all right, period is equal to 2 pi over b, and this is where the b variable represents the coefficient on the x. So obviously here, what's the coefficient on the x up there? 4. Okay, so the period is going to be 2 pi divided by 4, which is really pi over 2. Okay, so now the period has been shortened. Remember, it used to be 2 pi. Now it's only pi over 2. So when I put numbers in front of x that are big, it takes the period and shortens it. When I put smaller numbers like fractions, it takes the period and makes it longer. Now, on our graphs, they're all going to look the same because we're going to change the numbers instead of changing the graphs. Now, let's look at the graph now, so you guys can kind of help me figure it out. All right, and you notice how the graphs are it's more horizontal than it is vertical, and they go out longer than they do up and down. Now, how many units do we do always here? 4. All right, 1, 2, 3, 4. Now, used to be that last one, we've always been putting 2 pi there because that's been the period. Now, the period on this one has changed because of that 4 up there. So the last one now is not going to be 2 pi, it's going to be pi over 2. Now, when you get fractions right there, it kind of gets a little bit difficult to start halving them, okay? But let me show you a trick to halving a fraction. All right, I'm just going to go to the side and make up a random fraction like 3/5. Okay, so anybody knows this. You know a shortcut on how you half a fraction? All right, let's see. What's half of a half? A fourth. What's half of a fourth? An eighth. What are you doing to the denominator? You're doubling the denominator. Okay, so if you take the denominator and you multiply it by 2, that's the same thing as halving a fraction. Okay, so half of 3/5 would be 3/10. All you got to do is take that denominator and multiply it by 2. Okay, so now let's figure out what's going to be half of pi over 2. Pi over 4. Okay, and now let's half again. What's half of pi over 4? Pi over 8. Okay, so every unit there is a pi over 8. So this is 1 pi over 8. This would really be unreduced. It would be 2 pi over 8. So the missing one there would be 3 pi over 8. So you got 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, which is pi over 2. All right, did that make sense now? So, you know, when you got nice even numbers like 2, it's really easy to do. Okay, but when you got fractions, you got to really think about that. All right, now, so we got the period straightened out, with that last one being pi over 2. The amplitude's what there? 2. So it's going to go up to 2, down to -2. Okay, now let's draw the graph. Okay, so now it's a positive cosine graph. So start at 2 and go down. Okay. What if it was, I want to change it to -2 just to mess with it a little bit? No? Okay, fine. So what if it was -2? You start down, instead of positive 2, you start at -2 and go up. Okay, so start at 2, and then so at pi over 8, it's going to be at 0. All right, pi over 4 is going to be at -2, and then 3 pi over 8 back at 0, and then pi over 2 starting over at 2. And so y'all understand something that I didn't mention earlier that I should have. These go on infinitely in both directions. Okay, they don't stop. But what we do is we only graph one period, because every if it just kept going, it would just do the same thing. Okay, so let me draw it and I'll show you what I'm talking about. Question? Why did I like skip? Because I'm halving it. Okay, so this is the end mark, right? So halfway to it would be this one. Okay, so I like half it 2 times. Half of pi over 2 is pi over 4, and then halfway to pi over 4 would be right there. Half of pi over 4 is pi over 8. And so once I get this one, I'm seeing that each unit is pi over 8, and now I can fill in the third. Okay, now let me kind of comment about what I was saying here. So really and truly, the graph doesn't stop right there. It keeps going. Okay, so over here, that would be like negative pi over 8. So at negative pi over 8, where would it be at? 0. And then negative pi over 4, it would be down at -2. You'll get the idea that they keep going. They don't stop, okay? But we only graph one cycle. That's all we really need to see. All right, now let's do this. Let's look at this, how we can check this on the graphing calculator. Okay, so get your graphing calculator fired up. Put your key in it, give it a little gas. You go to Format. So it's like second zoom, and then turn it on. All right. Now let me clear this one out. All right. Let's punch this one in. Oh, I'm sorry. Let's be sure to do this first. Because our angles here are like this, we're measuring them in radians, right? So your calculator needs to be in radian mode. So go to mode. Okay, be sure it's in radian mode and not degree mode. Now, really, if we wanted to here, you don't ever see this, but you could do this if somebody really wanted to. Like, instead of right here at pi over 4, instead of putting pi over 4, what's that in terms of degrees? It's not 30. Pi over 6 is 30. Pi over 4 would be 45, okay? And like the pi over 2 would be 90. So if you did it in degrees, you could label these in terms of degrees instead of radians. But you very rarely see graphs done in degrees. They're usually done in radians, okay? So that's why our calculator needs to be in a radian mode. All right, let me go back to y equals. Now I'm just going to type it in, 2 cosine 4x. Now, normally when we graph, we hit like zoom 6, don't we? Because zoom 6 gives me a graph from negative 10 to positive 10, negative 10 to positive 10, okay? But we don't want that, do we? All right, we want the graph to go from, what's this value right here? 0 to pi over 2, okay, on the x's. And we don't want it to count by ones. We want it to count by pi over 8s. And on the y values, we don't need negative 10 to positive 10. We only need negative 2 to positive 2. So we have to change the window. Okay. So before you hit graph, so that we can make the graph on the calculator look like my graph on my paper, you go to window, and we're going to change the window up. Okay. Now, the x minimum, we want to be 0, right? Because we're starting right over here at 0. And we pretty much start that way every time. Now, what about the x max? Pi over 2. Okay, so you push in pi over 2. Now, don't freak out. When you push it in, it's going to, I can't get it punched in. It's going to change it to a decimal, okay? That's no big deal. So if we hit pi over 2 and then hit enter, it switches it to the decimal form, which was 1.57. Now, the x scale, yours is probably set at 1, okay? Now, the x scale is, what are we counting the x units by, which is usually 1. But in this case, we're counting by what on our graph? Pi over 8, okay? Pi over 8, okay? And it'll change that to a decimal. Now, y min and y max, what are my y values that I need? I've got negative 4 and 4. Really, I need to be what? Negative 2 to 2. All right. Now, the y scale, that means what the y's are counting by. They're counting by ones. Now, would it be okay that the y's just counting by ones? Yeah. Yeah. If you wanted to, you could do by twos. That would be okay. All right. Now, my window's set so that it matches the window that I made on my paper on my sketch. So I'm going to hit graph, and it should look the same that it does on my paper now. Y scale, you just do 1. All right, now see how you can make the calculator do the same thing that you've got? So this is a really good way of checking. So if your calculator doesn't say what your graph has, messed up. Question? All right, go to the format, so second zoom, and be sure the axis is turned on. Okay. All right, let's do another one, and we'll do the next one on the graphing calculator too if you got a little bit lost there. All right, let's try this one. Okay, let's do y equals, let's do negative 5 times sine of 3x. Okay, let's go a little faster this time. What's the amplitude? Somebody said 5 or negative? Just 5 because it's absolute value. All right, period. Is 2 pi divided by b. Now, what's my b value? 3. Okay, so it's going to be 2 pi divided by 3. Notice that won't simplify like it did last time. So notice if you, chances are if you have like an odd number down there, then it's not going to simplify. But if I had an even number, it would reduce, wouldn't it? Now, all right, let's do the graph. Oh, and by the way, let's think about this. If I don't have a coefficient, the understood coefficient right here would be 1, right? And so 2 pi over 1 would just be 2 pi. So that's why, like on our standard baby graphs, the period is just 2 pi, because it's like 2 pi over 1. Now, let's draw it out. Okay, so we'll go 1, 2, 3, 4. All right. The last one on our normal, easy little baby graphs is 2 pi. What's this one going to be at the end? Yeah, 2 pi over 3. Okay. All right. So you're going to half it. So to half it, which will be right here, right? That's halfway. Half of 2 pi over 3. Take the denominator, multiply it by 2. So it'll be 2 pi over 6, which is pi over 3. Right, when you got a fraction, you just multiply the bottom number by 2 to half it. Now, let's half again. What's half of pi over 3? Pi over 6. Okay, so every unit is a pi over 6. So you got 1 pi over 6, 2 pi over 6. The missing one would be 3 pi over 6, which is pi over 2. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which is 2 pi over 3. All right. Now, question? Anybody? Yes. Yes. Right. So it's still going to be, amplitude's still going to be 5, and it's still going to go down to negative 5. But what's going to change the negative part on it, what sine normally what starts at the origin and goes up. So now that it's got a negative, it's going to start at the origin and go down. Okay, so let's do that. So since it's sine, it starts at the origin and then goes down at pi over 6. So where's it going to be at pi over 3? 0. Okay, pi over 2 is going to be up at 5. All right, and then 2 pi over 3 will be back at 0. Here goes our curve. Here we go. All right, now, and be sure that you don't draw, they're not lines, okay? They're curves, make them nice and curvy. Now, all right, do y'all want to look at the, you want to do it on the graphing calculator now? Okay, all right, so go back to y equals. Yeah, so we're going to do negative 5 sine 3x. Okay, now, if I hit graph, remember that graph we did a while ago where we were counting by pi over 8? It's not going to look right, okay? So we have to change the window. Okay, so x min, does that still need to be 0 then? Yeah, okay. All right, what about x max? Yeah, 2 pi over 3, because that was our last number over there. So here we go, 2 pi over 3. Switch it to a decimal. All right, x scale. So what is every unit? Pi over 6. You're counting by pi over 6. Okay. Now, what about y min and y max? Right, negative 5 to positive 5. Okay. Y scale 1, is that still okay? Yeah. You can count by 2s. That would be okay. It doesn't really matter. All right. So go to my graph, and it should be pretty much the same thing that I've got there. Okay, so now you have a way to check every single graph now. And so what's going to happen is you're going to make mistakes. Okay, mainly the mistakes are from calculating the period. Okay, when you get harder problems, it's going to be harder to calculate the period, and your graphs won't look the same. So you'll know that you've missed a graph if you've missed it. Now, all right, let's do another one here. Now, this time, my coefficient or my b, yes. Yeah, when you do zoom 6, it goes back to -10 to +10, and it scales everything by 1. Okay. Now, all right, let's try this one. Let's do y equals 4 times cosine of pi times x. Now notice that I changed, we call that the b, right? I changed the b into a form of pi. Okay, it's a little different. All right, amplitude, that's pretty easy. That's just 4. Okay, all right, my period is 2 pi over b. And now my b value is pi, right? So this would be 2 pi over pi. And so guess what happens there? They cancel out. They go away because I ate both of them. They were good. They were apple pies with ice cream. Okay. Yes, still going to do it in radians, okay? But what's going to happen is this. All right, listen to this so you can kind of get a big picture of what happens. If your coefficient is in terms of pi, that means your period will not be in terms of pi. Okay? No, it's just not in terms of pi. You don't have to change anything to degrees. You don't have to change anything. Okay? Yeah. The coefficient. So if it was 3 pi, then your period would be 2/3. Yeah. Okay. Now, so the period here, since the coefficient was in terms of pi, the period will not be in terms of pi. Okay. Now let's graph it. Here we go. 1, 2, 3, 4. Last one's going to be 2. So half of 2 is 1. Half of 1 is 1/2. So count by half. So 1/2, 2 halves, 3 halves, 4 halves is 2. All right, amplitude was 4. All right, it's a positive cosine curve. So where's it going to start and what's it going to do here? It's going to start at 4 and then go down. Okay, so at 1, it's going to be at -4. All right, at 3 halves, it would be at 0. And at 2, it would be back up at 4. Yes. Uh-huh. No. The table was just to see where the values come from. And that was from the unit circle, right? So the unit circle really helps me develop what the graph looks like. But once we've done it, once we've seen it, we know where it comes from, we don't do that anymore. Okay? We just follow a pattern. And that pattern is what cosine starts up, goes down, sine starts at the origin and goes up. We throw negatives in the front, just do the opposite. Okay. Now, all right, do y'all want to do this one on the graphing calculator? Or, okay, we'll skip it then. All right. But certainly, y'all can check every single one on your graphing calculator. Now, let me do another one with you. I think this will be like the last one, okay? This is like a long lesson today. I know it's long and drawn out. All right, let's try this one. All right, I'm going to mess with you on this one. All right, amplitude's 8. Nobody's going to have any problems there. But the period. Okay, 2 pi over b. All right, but I'm going to let you stop and think just a minute, okay? So a lot of people are going to say, well, the b would be like maybe 5. It's not right. It's 1/5. Okay, x over 5 is the same thing as 1/5 x. In fact, if when you copy it on your paper, if you want to copy it as 1/5 x, that might be better. Okay. All right, but the b value there is 1/5. Now this looks pretty nasty right here. So you're going to get 2 pi divided by 1/5. Well, that's like a very nice number, right? 2 pi over divided by 1/5. Okay. You don't worry about the x. Just do the coefficient. Okay. So the coefficient would be 1/5. Now, think of this as not just a nasty fraction, but think of it as division. And division is easy as pi. You just flip the second and multiply. And you're going to have to do that a lot when your coefficient's a fraction. Okay. So get used to this, doing this. All right, 2 pi times, so the reciprocal, flip the second and multiply, would be 5 over 1, or really you could just say 5. Okay, so 2 pi times 5 would be 10 pi. Okay, so that, notice a fraction is going to make the period lengthen out. It's going to make it a lot longer when you have a smaller number out in front. When you have a bigger number, it's going to make the period shorter. Now, on our graphs, you're not going to be able to tell because all we do is change the numbers. Okay? All right, let's draw it. So here we go. 1, 2, 3, 4. Last one would be 10 pi. Okay? All right, let's half it. Half of 10 pi is 5 pi. That worked out real nice. Now, half of 5 pi would be 5 pi over 2. Okay, isn't half and something dividing by 2? Okay, so if you got an odd number, it's just over 2. Now, so you're going to have to watch it really, really close right here. Y'all look at me, okay, because this is where people get lost a little bit. Every unit is 5 pi over 2. So this is 5 pi over 2. Now this one, you wouldn't say 6 pi over 2. Okay, if this one's 5 pi over 2, then this one's going to be 10 pi over 2. You follow me there? So if that's 5 pi over 2, that's going to be 10 pi over 2, which is 5 pi. Start over again. 5 pi over 2, 10 pi over 2. So now 15 pi over 2. And then the next one, say it is something over 2. 20 pi over 2 is 10 pi. All right. Amplitude. So remember when I told you the amplitude was the easy part? You really believe me now, don't you? That's nothing, right? 8, negative 8. All right, it's cosine. Was it cosine? Yeah. All right. So cosine graph, so positive cosine graph. So start up at 8 and then go down at 5 pi over 2 to 0. And so at 5 pi, it's going to be down at negative 8. 15 pi over 2 is going to be at 0. And then at 10 pi, it's going to be back up at 8. Okay. Now, we won't graph it, but let's think about how would we set the window. Okay. What would the x min be? Nuh-uh. That would be the y's. Min would be 0. Max would be 10 pi. The y min and max would be negative 8 to positive 8. And the x scale would be 5 pi over 2. Okay. Now, all right, on the sheet that I gave, okay, on the sine and the cosine curve, I don't have it written up on my board. I'm kind of behind over there. All right, right here. Can y'all see that? Probably not. Okay. That says, all right, 9 through 15, and then 37 through 41, odds on all that. Okay, so every one that you do is an odd problem. 9 through 15, 37 through 41, all the odd ones. And keep in mind, I'm going to email you a file that's got that graph paper on it, really nice graph paper that you can use, or you can sketch them. Okay. Just know that on the test that you'll actually have to do them on graph paper. Okay. So at least, you know, on maybe one homework that you do, probably towards the end. Actually do it on that graph paper kind of later. These are easy, so you really don't need graph paper. You can sketch them out pretty good.